As we know, the solar system revolves around the center of the Milky Way. From the knowledge of previous chapters, this means that the solar system is driven by the gravitational field of the Milky Way. We call its power the primal power of the solar system. This also causes all bodies in the solar system to be grarotated. The conclusion from this is that all bodies in the solar system rotate in principle in the same way. And all planets are driven in the same direction by the Sun's rotating gravitational field and run around this. We actually don't know exactly how strong the gravitational field of the Milky Way is. But according to our rough estimate, in order to keep the whole solar system running, there is an acceleration needed of approximate. This primal force, acceleration, is equal to the rotational force of all bodies in the solar system. With this primal force for the solar system, we will try to explain below why the movements and events in our solar system are the way they are. To simplify things, let's look at them as if all bodies moved on the ecliptic plane. The axes of all bodies are perpendicular to the ecliptic. One of the most important questions about the solar system is, where does the heat energy of the Sun come from? Therefore, nobody doubts that the heat energy of the Sun was created by a fusion reaction, just because there is no other possibility. Now we know that a grarotated body also generates heat. Could this be the real cause of thermal energy? The Sun is thus grarotated by a primal acceleration, AU. As we have already explained, angular velocity of rotation of a grarotated body is faster in interior than in exterior. As a result, the interior of the Sun is rubbed, heated, melted and glowed. The total rotational energy of a spherical body accelerated or grarotated by O is the same. We assume that the third part of the energy is thereby completely exhausted, and when the maximum rotation speed of the Sun is reached, then it is completely converted into heat. After deriving the third part of energy over time results in a power of This energy only comes from this third partial energy. Possibly some of the second partial energy can also be converted to heat because of the internal frictional resistance. Thus, the second partial energy has many times more energy than that of the third part. The third energy is actually just a small remnant of the total energy that the Sun possesses. So the Sun has enough energy. In all cases, one thing we can say is that the fusion power plant inside the Sun, once built haphazardly by terrestrial humans out of desperation, can be shut down. It's just superfluous. On all planets, including Earth, heat is generated to a greater or lesser extent by grarotation, both constantly and eternally, depending on how big the body is and which states the matter has. The rotational speed of a grarotated spherical body can usually be calculated with the following equation. As said, this equation is only intended for the rigid body. Because the Sun is not a solid body, it rotates faster on the inside than on the outside due to gravitational rotation. And most celestial bodies have a core, which therefore also rotates faster than outside. About rotary motor effect, we have seen that a celestial body can accelerate another body with its gravitational field, like an electric motor with its electromagnetic field, the runner. The rotated core of the body also has such a rotary motor effect with which the outer mass of the body is further accelerated. However, if we consider the Sun as many cylinders assembled into one another, the rotational speed at the equator can be calculated using the basic equation of inertia. This formula for the velocity was developed on the assumption that it was due to grarotation alone, ignoring that it could be further accelerated by the faster rotating Sun's core. Then this should be their minimum rotational speed, and the speed of the Sun at the equator should be slightly greater than 1830 meters second. Thank you very much for your attention. See you next time.